Hello, this is Mr. Frank, and welcome to I Can Solve Scale Drawing Problems, Learning Target 60, Day 2. Alright, remember the scale factor. The scale factor is a scale where we're using the same units, and it is in simplified form. So, to find a scale factor, we're going to have different pieces of information. We're going to have a model or a drawing. You might hear either one of those words. And we're going to make that the numerator, and we'll have the actual object, and we're going to make that the denominator. I think this will become more apparent as we get into an example. So let's say I traveled 200 feet to the corner, and yeah, I needed a map to do it. You know, I wasn't really sure how to get to the corner. So on the map, the distance was 10 inches. So I want to find out the scale factor. So the model distance would be what's on the map. So the model length or distance would be 10 inches, and the actual length, we're given the actual length as well, it's 200 feet. So I have a relationship between the model length and the actual length, and I'm going to use this to find my scale factor. I need to convert, I can simplify this. I have 1 inch to 200 feet, and that actually is my scale, because a scale can have different units. But a scale factor needs to have the same units. So I'm just going to rewrite 1 inch to 200 feet down here, and I'm going to change my feet to inches. So 200 feet, to change it to inches, I'm going to multiply by 12. I do that in the denominator, and so I'm changing my units, and I get 1 inch over, it would be 240 inches. But with the scale factor, we actually don't have to put the unit, because we know the unit is the same. So my scale factor is 1 to 240. Notice on this page I have green in the background here. That represents that across this whole way we have the model length in our numbers. And the yellow in the denominator, that signifies across the whole way we have the actual length. And you're going to see that throughout the video to help remind you that we put the model length on top and the actual length on the bottom, or the denominator. So now let's find the scale factor. Notice I put up here, in case you need to remember the scale factor, model length over actual. So let's see what the scale factor is for this model. Let's see, we need the model length. So the drawing is the model length. So that's a 3, and the actual object is 6 centimeters. So model length over actual. We have 3 over 6 centimeters for both. We'll simplify that, and we get 1 over 2 centimeters. So that's simplified. Our scale factor is 1 centimeter, 1 over 2. You can also write that as 1 and then a colon 2. So now let's find the length of an actual object. Now, we can find the length of the actual object when we're given the scale factor and we're given the drawing. And that's what we're given here. So the scale factor is 1 to 2. And the drawing, here we have 3 centimeters. So let's look, model length over actual length. We got our green and our yellow to help remind us. So I know my scale factor is 1 over 2, and I know my model length is 3 centimeters. I don't know what my actual length is, though. That's what we need to figure out. How are we going to figure that out? There are a few ways we can figure it out. Here's one. We could look for a relationship in the numbers. So I could look for an equivalent fraction. So in order to make 1 into 3, I can multiply that by 3. And whatever I do to the numerator, I do to the denominator. So I would have 3 centimeters over 6 centimeters. So my answer would be the actual object would be 6 centimeters. So that's pretty cool, and that's what it would look like if I drew it. So there's the object. So now, if I want to find the length of the drawing, so what's the length of the drawing given the scale factor of 1 to 2, and I'm also given the object. Notice that's the same object. Last time we were given the drawing, and we needed to find the object. Now I'm giving you the object, and we need to find the drawing. So I know my object is 6 centimeters. I've got model over actual. So my scale factor, I know that my model scale factor, my smaller part of my scale, is going to be 1 to 2. And my model is smaller than my actual in this case. So I need to find the model length, and I know 6 centimeters. So we can look for a relationship. Here's that same relationship. We multiply the denominator, 2, to get to 6. We multiply by 3. We do the same thing in the numerator, and we get to 3 centimeters, and there's our drawing or our model representation. So you could find the drawing if given the scale factor in the object. And here this slide summarizes it. If you're given the scale and the original, you could find the drawing or the model. If you're given the scale and the drawing, you could find the original. And if you're given the original and a drawing, you could figure out the scale. So in the problems you'll be facing with scale, you'll be given 2 of these, and you'll need to find the third. You may have to work out, units might be different. Maybe you're given a scale factor with the same units. Maybe you're given a scale with different units. So you'll have to make sure you watch your units. We'll do that tomorrow in class as well. So finding the actual measurement. Let's do a problem here. An architect's drawing for a new school library is 8.4 inches long. The scale on the drawing is 1 inch equals 5 feet. What is the length of the actual library? So I've got my green and my yellow to represent model and actual. I know my scale is 1 inch to 5 feet. We're given that. And I also know that my model is 8.4 inches. I don't know my actual length. And that's what we're going to try and figure out. Now, so let's see. Before we look for a relationship in the numbers, that might be a little harder here because we have a decimal. So let's try cross product. We learned that. So let's try that. I can cross here. So I can have 1 times x is equal to 5 times 8.4. And that's what I have for cross product. So I got my handy dandy calculator, and I've got x equals 42. All right, hey, I solved for x. That wasn't too bad. So the actual length of the library is 42 feet. So x here would equal 42 feet. So now your turn to do a scale drawing. So here's a house. The scale is 1 foot to 30 feet. The drawing of the house here, let's take this length here, is 2 feet long. That's the drawing. I know it doesn't look like that on your computer screen, but that's the actual drawing is 2 feet long. So I want you to find out how long the actual house is. So pause here, figure it out, and then come on back. All right, welcome back. So let's see how you did. So we have our scale factor, 1 foot to 30 feet. This is model, and this would represent actual. So that's our scale. We know the model is 2 feet long, so we need to find x. So here I'm going to find a relationship rather than cross product, because we just did cross product. So my relationship I can see here is 1 to 30. Now notice the last time when I looked for a relationship I looked across. This time I'm looking down. You can do it either way. Either way works. So we find 30. I'm going to find whatever I do to one side, I do to the other side. So 2 times 30 would be 60 feet, and the actual house would be 60 feet long. I hope you did well on that. Now let's construct a scale drawing. So Heidi's designing a garden that's 16 feet long and 12 feet wide. Let's determine how long each side should be for a scale drawing. The scale is 1/4 of an inch, 0.25 inches, to 4 feet. So let's start with length, because we need to figure out length and width separately. So let's find out length. The model length, do we know the model length? Well, we do know the scale is 0.25 inches to 4 feet, and we need to figure out the model length. So that's what x is here. And we know that the actual garden is 16 feet. So I'm going to use cross product here. I have 0.25 times 16, and 4 times x. So I do my multiplication there. I need to do a one-step equation, divide by 4, and I get x equals 1. So the length will be 1 inch. All right, that was pretty good, figuring out the length. Now I have the same problem here. I want you to find out the width. So the width is 12 feet. The length was 16, so you have to do this with 12 feet now. I'm going to pause, and you can do that. All right, welcome back. All right, let's see how you did. So you should have an equation that looks like this, and you cross multiply, and you would get 3 is equal to 4x. You divide by 4 on both sides, and you'd have 0.75 inches, 0 and 75 inches, or 3/4 of an inch. If you got that, give yourself a pat on the back. If not, maybe rewind the video a bit and see what you can do. Alright, so now let's draw the model. So we know the length is 1 inch from the last slide. We know the width is 3/4 of an inch. So it would look something like that. And I made it green because it's a garden. I hope that's okay. And so that would be my drawing. Alright, so in summary, we talked about 3 things today. We talked about original objects. We talked about drawings. We also called them models. We talked about scale. If you're given 2 of these, you can always determine the third, and that's typically what happens when you're given a problem with scale. So in your own words and in your video guide, I want you to summarize how we figure out either the original objects, the drawings, the scale when we're given the other 2. So pause and do that, and then come on back. All right, welcome back. All right, we'll end with this. What were you reminded of and questions that you have? Hope you enjoyed the video.